Welcome back, everyone. We will be building a Proto25 2.5-inch quad today. It is advertised as a long-range ripper, so I will look at 3 criteria. Obtain and maintain GPS satellite lock, consistent link quality in any orientation, stability, aerodynamic, and usability. All the contents at a glance. User manual with building tips. And a sticker, of course. It's pretty nice to have a printed manual with a breakout diagram. Something uncommon found in other frame kits, battery sticky pad. Carbon base frame in its own zipper bag. Top carbon fiber plate. Semi-rigid frame parts and accessories. Unusual design of the 3mm thick base plate. Arms are tapered on one side. The fuselage is also hollowed out aggressively, with reduced thickness at the center. Bottom view of the 2mm top plate. Battery strap slot in the middle. Bottom frame is pretty light at 9.8 grams, thanks to the big openings and tapered arms. The upper side of the top plate also has a tapered design. It weighs 5 grams. 3D printed parts take up most of the frame. 2 proto straps are included. I will get to that later. Beefy camera mount for DJI-03 camera. Walk Snail, Vista, and Polar variants are also available. It feels flexible yet tough to resist impact. VTX mount for DJI-03. Other variants can be specified. GoPro style mount, GPS, receiver, and antenna tail mount. It accepts nano-sized GPS at 12mm width. Arm bumpers double as landing pads, flight controller adapter mount, and LED housing. VTX antenna tail mount. 27mm aluminum standoffs and plastic spacers. WS2812 single LED light with patch wires. Lastly, the screws included are titanium. Total weight of the frame with the shorter strap is about 27 grams including screws, about average for quads at this size. I am using the Hake RC7226 AIO Whoop style flight controller in this build. 40 amps ESC, 5 UARTs with barometer built in. Convenient socket connector for DJI-03 air unit. Motors are RC iron power 1204 5000 kV. Smooth and efficient, good for long range. Betaflight Super D ELRS receiver. At 1.1 gram dry and less than 2 grams with dual antennas, it is a good match for this P25 platform. Flywoo GM10 Nano V3 GPS. Patch wires and copper tape are included. The GPS module weighs 2.5 grams. It is not easy to jam the GPS into the tail mount. Slowly work your way in and soften the material by bending and stretching. There, the GPS antenna is fully exposed. Make sure the module sits squarely in the mount. apply flux before tinning the pads. I should have used a finer soldering tip for these pads. Make sure the tiny pads are not bridged. This board is not easy with tiny pads sitting next to each other. My eyes are sore. For a cleaner look, motor wires are soldered to the bottom side pads. C-shaped larger pads for power leads are appreciated. Board. Do not use this UR2 unless you are using the DJI remote. Gentle tug to ensure a good joint. With ELRS receiver, use other ports like UR3 instead. Twist the wires in group to stay organized. Hook up the Super D ELRS receiver. Make sure the wires are at appropriate length as space is very limited. Slide the heat shrink in, but don't apply heat yet. Install the antennas. This will be covered up after the final fitting. Final check on these tiny solder joints before the next steps. Solder the GPS wires. Give them a gentle tug to check. Finally, the LED light that weighs 0.3 grams. Soldering is much easier with a fine tip. Hook up the LED. 5-volt, 85 decibel piezo buzzer, good size and weight for its performance. Weighs 0.7 gram. Almost there. Tug lightly to confirm the good joint. Insulate the pins with a piece of tape. Use a multimeter to check for shorts. It is a must to prevent the magic smoke, Most Whoop-style AIO have ESCs organized diagonally. Make sure your motor wires are long enough to compensate the offsets. You may want to twist or braid the wires before taking measurement. Thanks for supporting my channel. You may find the discount link in the description. With everything soldered, final check before mounting them onto the frame. Front and rear motor wires look good. Receiver will sit at the back while the LED hides beneath the flight controller. Buzzer will be placed behind the camera, GPS at the far back. Power lead exits from the rear according to the manual. Let's set up Betaflight and verify everything is in working order. Only the receiver's powered, GPS, LED, and buzzer are not. Let's plug in the pack and see. Now everything is powered. So only a single port is powered by USB. With the ports correctly configured, all connected devices should light up in the panel. Tilt the flight controller to check the gyro and accelerometer. Port 2 on this board is reserved for DJI remote only. CRSF does not work with it. Adjust the alignment of the flight controller accordingly. This board needs 45 degrees yaw in this orientation. After changing to UART3 for the receiver, all channels started working with my inputs. Make sure the auxiliary channels are responding as well. Let's check the order of the motors. None of them are spinning? For some reason, the preloaded BLHeli-S firmware doesn't work, so I flashed the ESCs with BlueJ firmware. Then go back to Betaflight and enable bidirectional D-shot. Motors are now working as it should. Reorder them as needed. With the electronics out of the way, it's time to assemble. Push the LED housing into the frame opening. Make sure it is flushed with the bottom surface of the frame. One standoff of the mount is too high to clear the socket connector on the flight controller. Carefully cut away the obstructing part using a craft knife. Only remove as much as needed without cutting off the whole arm. This looks about right. It is possible to fit a 20 by 20 stack into this frame, but not likely with the LED mount beneath with the limited vertical space. M2 12mm screws to secure the housing and AIO flight controller. Insulate the back of the LED before mounting. Then mount the flight controller on top of the LED housing. Make sure it is seated squarely. The included M2 5mm screws are too long for my motors. Turns out that it is a bit longer than 5mm. Take my M2 5mm screw for comparison. Arm guards double as landing gears, come in 2 pairs. The openings are big enough to clear the screw heads, hence all motor screws are at the same length. Weight saving is not significant with the 3 holes mounting design. We will see if it holds up. Tuck in the wires to prepare for the next steps. Route the LED wires towards the rear, away from the USB port. These wires are at good lengths. The receiver will sit next to the flight controller at the rear. This is where the receiver is supposed to go according to the manual. Route the antenna wire along the belly to the tail mount. No need to tape the buzzer down. It will stay between the O3 air unit and the camera. Plug in the O3 cable. Try to shorten the wires as it will be cramped when the O3 is mounted. Whoops, antenna wire should exit from the rear. Shove the O3 air unit in and mount the camera. Just realized I forgot to swap the antenna. No worries. Pry the mounts open and it's ready to be worked on. Simple as that. I have never seen a wacky battery strap like this. The Proto strap is a 3D printed strap with TPU material. It's stretchy, so there is no need to use brute force to secure the battery to the quad. The flat side of the collar sits against the battery. Go through the opening and lock the tab in. And then loop it back and through the collar. The stretching and tackiness of TPU helps keeping the pack in place. Optional GoPro style mount. Can't believe it has enough space for that in a top-mounted battery quad. I will strap the second ELRS antenna to the O3 pole for now. GemFan D63 2.5 props installed. Sticky battery pad is next. This thing is pretty sticky when it is clean. It sticks so well that the strap becomes almost optional. Peel off and attach to the top plate. Dog Comfort 650 pack. Pretty beefy for a 2.5-inch quad. Let's see if I can do this quicker this time. Pull, lock the tab in. And through the collar. Thanks for supporting my channel. You may find the discount link in the description. At 213 grams, I can potentially use a larger pack and still stay under 250 grams. The quad was plugged in and left on the ground for about 4 minutes. Still got 0 satellite lock when taking off. The Maiden footage is unstabilized. Default Betaflight 4.5 PID. No stutter nor vibration. Got 3 satellites only after 5 minutes. LQ dropped momentary, despite being relatively close. Let's try leaving it plugged in for longer before takeoff. The quad was plugged in and left for about 8 minutes. I got 8 satellites locked. Let's try some aerobatics. Split S is a breeze, and the control feels linear. Dives are just as smooth. There's no prop wash, stutters, or oscillations. Uh-oh. LQ tanked at certain angle, and it's not a good sign. Seems to recover, okay? Let's bring it in to check. Turns out that the ELRS antenna position and orientation are the culprits. At this angle, the rear antenna was mostly blocked by the quad itself. The top antenna's tip pointed at me, and also partially blocked by the battery. Initial thought, easy build and it handled well. Maybe something could be done with the other two areas.